Section 3.9, linear functions. Our objective today is going to be to define and use linear functions in applications. First, to start, we call a linear function some function written as f of x that's equal to mx plus b. Now, in textbooks, when you start to learn about polynomial functions, you'll hear that you could write it this way, which is the same thing. Okay, ax plus b. And traditionally, you start with the lowest letter of the alphabet as the first coefficient, which is why it's ax plus b. But since we use m as our slope already, we're going to leave this as an m here. But this is analogous, okay? They're the same thing really here. Now, m, again, is the slope. So it's the change in y over the change in x. But this is like our y right here, okay? That's our dependent variable. So f of x is really our y. So instead of writing delta y over delta x, we write delta f of x over delta x. Okay, so the change in the function height over the change in the x coordinate. So again, this is like our y coordinate for all of these examples. First, we want to find equations of linear functions h and k using the given information. So in part A, we're told that h of 3 is equal to 2 and h of 5 is equal to 7. Well, here's what this means to me. If I put an input of 3 into the function, okay, I put the input of 3 into the function, the output is a result of 2. That's what this first part means right here. The second part means if I plug a 5 into the function, we don't know what the function is, but if I plug it into the function, the output here is going to be 7. So really what we have are inputs and outputs. Inputs and outputs. Well, traditionally, we realize that these are really the x coordinates, or the independent variable, and these are like the y coordinates, or the dependent variable. So we really just have coordinates here. So it looks like we've got 3, 2, and we've got 5, 7. So since we've got 2 points, we can find the linear function between those 2 points, the same way we would find any linear equation given 2 points. Okay, so let's go ahead and take a look at this now. We want to go ahead and see that this is my y, or my h of x, and this is my x. So remember that slope is delta y over delta x, but y in this case is h of x. So it's really going to be the change in y, so 7 minus 2, over the change in x, which is 5 minus 3. So this is simply 5 halves. Now, if this is 5 halves, our linear function now becomes the following. And when we have this set up this way, all we need to do is plug in one of the points. So if we pick one of our coordinates, I'll choose 3, 2, and plug it in. We could solve for b. But remember that the 2, okay, this 2 is really h of x. So we're going to put the 2 there, and the 3 is the x coordinate. That's going to go right here. So we're going to have 2 equals 5 halves times the number 3 plus b. At this point in time, I would multiply everything by 2 to get rid of that denominator, making it 4 equals 15 plus 2b. And if we solve for b in this case, we're going to end up with negative 5.5. Well, if b is negative 5.5, let's write down our final answer here. H of x equals 5 halves x. Now it would be plus b, or plus a negative 5.5, or just minus 5.5. Now let's take a look at part b. Part b says, if k of 0 is 4, okay, k of 0 is 4, and an increase of 5 units in the x causes a decrease of 10 units in k. Alright, so this is a little confusing at first, but let's start by using this part here. That means that the coordinate is 0, 4, based off the same thing we did for the last part. Well, that's just the y-intercept. How do I know that's the y-intercept? Because when x is 0, we are finding the y-intercept. So for this problem, our y-intercept, or the b value, is 4 already. So that means all we need to really find is the slope, and it looks to me like this is something about slope. I see increase and I see decrease, right? So an increase of 5 in the x. Let's draw this. So let's put a point right here, any point in space. An increase of 5 units in the x would look like that, but then a decrease of 10 units in k. But k is really like the y coordinate here. Remember, it's k of x. So it's a decrease of 10 here. So I'm really going over 5 and then down 10. So my slope is clearly going to be, as we can see here, negative. If we remember, slope is defined as the change in the vertical component over the change in the horizontal component. So this change in the vertical component is negative 10. The change in the horizontal component is positive 5. So negative 10 over positive 5 is going to be the slope. So the slope is negative 10 over 5. Well, that's just negative 2. So the answer for this is going to be k of x equals negative 2x plus 4. Again, the 4 comes from the fact that 0, 4 is our y-intercept. Let's also note that part A could be solved by using a system of linear equations. Okay, we can do that as well, but just for the sake of this, because we're looking at functions, we'll do it this way, but you could solve part A either using point-slope form. We did it with slope y-intercept, but you could also use systems of linear equations. If you plugged in those 2 points into standard form, you'd have 2 equations and 2 unknown. Feel free to try that on your own to verify that h of x is indeed what we got. Example 2, on a strength training test, a person scored a 140 on a scale of 0 to 175. Find the linear function rule and use it to convert this score to a scale of 0 to 100. So it's like you're taking a test, right? And the max score is 175 and the min score is 0, and there's any range in between. And you scored a 140 on this test. Well, we want to convert this 140 into a score out of 100. So now we're looking at a new scale that's out of 100 like this. So when I think about this problem, I say, well, an input of 0 is still an output of 0, but an input of 175 on the old axis, or the old scale, is an output of 100. So think of this as your inputs, and this is your outputs, or your x, and this as your f of x over here. So we could say that we technically have coordinates. We've got 0, 0 as a coordinate, and we've got 175, comma 100 as a coordinate. And eventually we're going to come up with a rule. And now, once we come up with that rule, which is our linear function, we have to remember that we still need to plug in 140 into the function to see what we would get as a result in the 0 to 100 scale. So let's remind ourselves that we're going to use this later. But again, this is like our x, and this is like our f of x, okay, or our y, either one. So let's take a look. We've got 2 points here. We've got the y-intercept 0, 0 already, and that's the x-intercept also. It's the origin. So we know that the b value is going to be 0. So really all we need to find is the slope. If we find the slope, we'll know what the function is. So let's go ahead and take a look. Remember that slope is change in y, which is 100 minus 0 over change in x, 175 minus 0. Or just 100 over 175, which is 4/7. It means that the slope of this function is 4/7. But again, we said a moment ago that the y-intercept was 0, because it was 0, 0 as a point. So this function is quite simple, actually. It just becomes 4/7 x. And that, sure, it's plus b, but b is 0. So that's our function. But we want to know, what is the score of 140 equal to out of 100? So let's take our 140, plug it into the function, run it through the function, and see what the output is. So let's put 140 into the function. And 4/7 of 140 turns out to be 80. So on a scale from 0 to 100, this person was at the 80th percentile, if you think about it that way. And you could make an analogy to any sort of normalized or standardized test where the percentage score, the raw score rather, that you get is converted to a normalized score that's out of 100. And if you got the 80th percentile on a standardized test, it means that you scored greater than 80% of your peers, and you scored lower than 20% of your peers. That's what the 80th percentile would mean. Now let's make one last note. A lot of you might say, like, oh, well, if it's a 140 out of 175, we could simply just use a proportion and do the following. We could say that 140 out of 175 is equivalent to what number out of 100? And you would end up just getting 80 for x there. So in the end, it would be the same answer, but without a linear function approach. Before we move on to example 3, let's take a look at some situations where we're going to translate real-life situations into linear functions. So we have a manufacturer of baseballs that spends $3,000 in fixed costs every month, so maybe rent and overhead and whatever else they have to pay for. And it's 50 cents for each baseball produced. And we want to find out the total cost of producing X baseballs in a given month, and then we also want to look at the domain. So let's think about this for a moment. Even if you don't produce any baseballs, it's going to cost you $3,000 that month. So that's like what the starting value is, where you're going to start paying. So for an equation like this, we could say that the cost function, doesn't matter what you call it, starts at 3,000 automatically. So that's like my y-intercept. It's got to start there. Even if x is 0, we still have 3,000. But we want to know that when it's 50 cents for each baseball, and we produce X number of baseballs, what would happen there? Well, it's like a slope. Think about it. If you produced 3 baseballs, you would take the number 3 and you would multiply it by 50 cents. That's what you would do here. If you produce 4 baseballs, you would just change that to a 4. If you produce 5, you change it to a 5. Well, this is X. So the 50 cents is like the slope in the front. So this ends up becoming 0.5x. So the cost function, again, is 50 cents times each baseball plus the fixed cost to rent that facility or whatever it may be of $3,000. The second part says, what is the domain for this function? Well, you have to think about the fact that you can't have a negative amount of baseballs and you can't have a fraction of a baseball. So technically, we're looking at positive integers, or we could just say the domain is whole numbers. Okay, number 2 says a snowboard purchased new for $600 loses $80 in value each year. Its remaining worth, or book value, B, Y years after purchase is given by, and we have to fill in that blank. Now we also want to look at the domain for this function. So it starts at a value of $600. That's how much it is worth in the beginning. So again, the y-intercept is 600 here. Like the last problem, it was 3,000. Next, it loses $80 each year. Loses. So this is a negative quantity. Every year it goes down $80. So after 2 years, it goes down $160. After 3 years, it goes down $240. So we're multiplying the 80 times however many years there are. So I know that the slope is going to be negative 80. Because every year it's going to go down 80. But we're not going to use x in this problem. We're talking about the independent variable being y years. So we put a y there, and then the function is just b of y now. So if we were to reiterate this, the book value after a given amount of years is equal to negative 80, because you're losing $80 every year, plus the initial value of $600 that you started with. So after like 2 years, you would drop $160 off of this $600. What you're going to notice, though, is that after a certain amount of time, you're actually going to have no value left for the snowboard. Think about it for a second. If 10 years go by, this becomes negative 800. You can't have a negative value. It would be like paying somebody else to take the snowboard from you. So there's got to be some sort of limitation. So we want to know, when does the value of the snowboard become non-existent, or when does it become 0? So if you just set this equal to 0 here, okay, we can solve for our domain. Well, let's go ahead and move the 600 over. And then we'll divide by the negative 80. We're going to end up getting 7.5 for y. That means after 7.5 years, the snowboard is worth nothing. So that has to restrict our domain in this problem. So we could say that our domain is the following. Okay, because again, in the beginning, the value of the snowboard is $600, but every year it loses $80 in value. So after 7.5 years, it's got no more value, so we have to stop there, which is why it's just less than 7.5 years. It can't equal 7.5 years. So our third example says, a hiker climbing Mount Jefferson left the 2,000 meter level at 4 a.m. and gained elevation at a rate of 500 meters every hour. And we want to find the hiker's elevation E as a function of time t after 4 a.m. And then we also want to look at the restricted domain here. So again, the hiker starts at 2,000 meters, so there's our y-intercept already. And we know that we're looking for the elevation as a function of time. So we know to put this right here because it's elevation as a function of time. Well, every hour, each person gains 500 meters per hour. So after 1 hour, we would take the 500 and multiply it by 1 hour. After 2 hours, multiply by 2 hours. So however many hours are there, so we'll call that t for time. Now, the hard part here is to recognize that the time is restricted. Well, first of all, time can only start at 0 hours. So we'd start with 0 hours for time. Now, after like 3 hours or 4 hours or 5 hours, sure, it keeps going up. But eventually, the person will reach the top of the mountain. There's a maximum elevation, which corresponds to the time it takes to get to the maximum height. So we'll say T max. T max is not known in this problem, but we know that after a certain amount of time, maybe 2 or 3 hours, the person reaches the top of the mountain. So whatever that time is would go in place for T max, if we knew the max elevation of the actual mountain. Example 3 says, at noon, a pump started emptying oil from a storage tank at a constant rate. At 2 p.m., there were 1,680 barrels left in the tank. At 5 p.m., there were 600 barrels left in the tank, so clearly it's going down because, again, it's emptying oil. We want to A, write a linear function to describe the situation, B, discuss how many barrels were in the tank at noon, and C, talk about what time the tank will be empty. So let's take a look at what we've got here. I'm going to underline what is important. So at noon, or at 2 p.m., 1,680 barrels are left, and at 5 p.m., 680 barrels are left. Okay, but this situation begins at noon, which is the key here. It begins at noon. So if I were to write a coordinate, my first coordinate in this problem would end up being 2, 1680 from these values right here. Why am I putting 2? Because we started at noon, so 2 p.m. is the value of hours that have gone by, and after 2 hours, there are 1,680 barrels. Well, at 5 p.m., that means 5 hours have gone by, and after 5 hours, there are 600 barrels left. So we have 2 different coordinates in this problem, and that corresponds over here, by the way. So we got 2 different coordinates in this problem, and just for the sake of this one, let's take a look at ways to solve this using simultaneous equations instead of looking at slope, y-intercept, or point slope form. So our volume function is a function of time. So volume is mt plus b. Okay, and mx plus b, so we're saying the volume is a function of time now. So t is our independent variable. The amount of time that goes by is the x, or the horizontal coordinate in this place. So for this situation, we can simply plug in. We could say, all right, well, we got 1,680 barrels left after 2 hours. That's the first scenario. And the second scenario says that we've got 600 barrels left after 5 hours. Well, take a look at this. We've got a system of equations here. We could solve this simultaneously, either by using elimination or by using substitution. Personally, it's simple to use elimination. If you negate the first equation or the second equation, you end up with a negative b in one of those equations, and then you can just add them together. So multiply either of these by -1. I'm going to choose the second one. So I'm just going to put a negative sign here, a negative sign here, and make this a negative sign here, and get rid of that. And now add straight down. 1,680 minus 600 is 1,280. 2m minus 5m is negative 3m, and the b's cancel. Dividing by 3, we're going to get a slope for m of negative 360. There's our slope right there. Well, if the slope is negative 360, we can take that number and plug it back in here to solve for b. So we can take negative 360, multiply by 2, giving us negative 720, then take the negative 720 and add it over here to get b. We'll get a b value in this problem of 2,400. So our function for this problem, for part A, our volume function, or the amount of fluid left in the tank, is going to be negative 360 t, that's the slope, plus 2,400. Let's take a look at part B now. Part B says, how many barrels were in the tank at noon? Well, at noon, it's when time equals 0, because the whole problem started at noon. So noon is like the origin for time, or 0 for the x-coordinate. So it'd be like plugging in a 0 here. So let's go ahead and do that. Well, if I plug in 0 for this, I do v of 0, I'm just getting the y-intercept, right? When you set x to 0, or when you set your independent variable equal to 0, in this case t, what you're yielding is the y-intercept. So do v of 0. It just means put a 0 here. That drops off. You're left with 2,400. So to answer part B, how many gallons are in the tank at noon? 2,400 gallons. Part C asks us, when will the tank be empty? So when is there 0 volume left? So all you need to do is set this equal to 0 and solve, because you're trying to find the time. You're solving for t, finding the time when the volume equals 0. So set the volume equal to 0 and solve for time. So take the 2,400, subtract it over, and then divide by negative 360. You're going to get a time of 6.6 repeating, which is 6 2/3 of an hour. And if you recognize the fact that 2/3 of an hour is 40 minutes, this means that 6 hours and 40 minutes have gone by since the beginning of the problem. Well, the whole problem started at noon, right? The whole problem started at noon. So noon plus 6 hours is 6 p.m. plus another 40 minutes is 6:40 p.m. So again, the starting value, the amount of oil in the tank, is the y-intercept, really, in the beginning. When is the tank empty? You set the volume equal to 0 and solve for time. The tank started at 2,400. It was losing 360 gallons every hour. So after 6 hours and 40 minutes, there was no volume left in the tank. All the oil had spilled out at that point. Your homework from this section is from 3.9, part written exercises, part problems, and then some review from page 152.